Gigapixel panoramas have become commonplace. These images convey a global sense of outdoor scenes. The ability to zoom into the smallest details is almost like being there. However, editing gigapixel images can be a very time-consuming task. For instance, here we clone an image region in Adobe Photoshop. While the area appears small at the current zoom level, in fact it contains many megapixels, and the operation takes many seconds to complete. Furthermore, standard photo enhancements such as brightness, contrast, and sharpness do not translate well to gigapixel images. For instance, a brightness and contrast edit performed for a chosen view and zoom factor, here applied to a house, does not work well for the overall panorama, which is now too bright. Likewise, adjusting the brightness and contrast for the overall panorama will produce an undesirable result for some close-up views. In this paper, we propose display-aware image editing. As the image is viewed on a display with a limited resolution, only a small subset of pixels in the image is visible at any given time, and therefore only this subset should be processed. We decompose each input image into tiles and compute a multi-resolution pyramid for each tile. Geometric registration between image tiles aligns them in a global scale-space coordinate system. All editing operations happen on the fly in display space. The original data is never modified. Editing operators are represented by bounding boxes in the global space. We only run operators which have a bounding box that intersects screen space. For gigapixel images, there is often no one setting for brightness, contrast, or saturation that works for all views and zoom levels. Our strategy is to automatically adapt the viewing settings by interpolating between user-specified values from nearby operator bounding boxes. Here, edits made to one region at one zoom level affect other regions at the same level. By turning this off, we can see the effect of our user-study-defined interpolation. As a result, new views across zoom levels are displayed with settings that yield a well-adjusted output. We now demonstrate other display-aware image editing operators. To enable image cloning and seamless blending, we introduce a display-aware variant of Poisson blending. Here we show an example where an area that contains 40 megapixels is copied and pasted instantaneously. Our blending method is based on Gaussian pyramids in combination with push-pull operations. Like all our operators, this process is only performed in screen space, making it highly efficient. Stitching panoramas is an expensive operation that usually involves solving a global Poisson system. We implemented a real-time method to stitch panoramas on the fly whilst new images are coming in, for instance from a biomedical scanner. In this example, 5 images are stitched together on the fly. Registration is performed in a display-aware fashion. Re-registration is possible at any time and may be needed when the view is zoomed in further. In summary, we introduce display-aware image editing and have implemented a set of common editing operators that can be applied in real time. Even though we focus on very large images, display-aware editing also applies to regular images on small mobile displays.